kind of task, this deep learning JS might be enough for first prototype.
Our next speaker is Marian Marinov, and I'm sure that everyone here who have been to software conferences in Bulgaria are familiar with him. You've probably heard him speak at least once, probably more times. So let's welcome Marian.
Thank you. Can you hear me? All right. So I'm Marian. I'm Chief System Architect of SiteGround. And in my spare time, I'm also teaching network security and Linux system administration in Sofia University. This talk actually is part of our network security courses in Sofia University. And the biggest problem for this talk was that it's usually 6 hours. So I tried to remove most of the things and keep the important parts here. The idea behind this talk is that every web developer should know these things, but most web developers that I encounter, they simply don't know them. And I wanted to share with you a list of things that you should know when you're securing your resources, your applications. Everyone these days should have SSL, right? Should. And most of these people usually get their SSL from SSL providers. They pay for them. You know that 2 years ago, Let's Encrypt started, and now we have free SSL certificates. So since last year, everyone is suggested to move to SSL. However, there are some use cases where you would really prefer to stay on HTTP instead of HTTPS. The first thing that we know about SSLs are that they're hierarchical, and the second thing we know about SSLs is that we need to protect them. Why we know this? Because the past 3 years, every year there was a compromise on major certificate authority, and because of this, before this happened, there were standards how to protect your site from problems with forged SSL certificates. In the presentations in this presentation, I have every second slide linked to somewhere. Because of this, I gave the presentation to Bogomil to put it on the website before we started. So the first thing you have to know is that there is a DNS record that allows you to define which certificate authorities are allowed to issue a certificate for your domain. So if you have this domain, 1h.cx, you can define which certificate authorities can issue certificates for this domain, and that's it. The problem with this is that you can shoot yourself in the foot pretty easily, because if you don't know, certificates authorities have this service OCP, what was that? OCPS, yes. And the OCPS has a problem that sometimes it dies, and when it dies, everyone that tries to open your site on SSL simply cannot verify the SSL. And usually when this happens, you should have a secondary certificate for the same domain, but from different certificate authority, so you would be safe. Most of us don't have a secondary certificate. And when this happens, you rush to go to buy a new certificate. But if you have defined here that only Let's Encrypt should issue certificates for your domain, now you cannot actually buy the new certificate until this record expires. And usually you don't set this record to 5 minutes. Usually you set it to weeks or months, which is a problem for you. Now you're stuck with one single certificate authority provider. And this is the DNS record for this. There is also a way to issue this the same thing. Okay, let's talk a little bit about the CA record. You have the issuing certificate authority main domain here. Then you have mail that is supposed to get email notifications if something happens to your domain, and you can say how much time it is valid for. So who is the issuer? Oh no, sorry, mistaken. The CA is valid with its time to live, and you have issue and issue wild. What's the difference? With issue, you can say that this certificate authority can issue certificates for your domain, while issue wild gives you ability to limit this to the wildcard, but not the top-level domain. Okay. The other problem with this is that you need to remember that browsers have their DNS cache also. So if you simply want to have this updated in the browsers, Firefox keeps this at 30 seconds, Google Chrome keeps this at 60 seconds, so you have at least 1 minute period before this is updated. I'll talk a little bit about this when we're talking about the rebinding attacks. The other thing is there is a HTTP header that allows you to do the same thing, but without touching the DNS at all. You have the public key pinning certain header, which gives you almost the same thing. However, it's not telling, you cannot say that you're particularly interested in this certificate authority. You have to pin keys. So you have to get the keys of the certificate authority. So the certificate authority key has SHASUM that you can get and put it here for your website. You define max H here, which this is from the RFC, and this is quite big. And you have the same problem here with, as with the DNS. You can define this, and because of the max H, all browsers will never try to consult another certificate authority if its key is not here. Also, this public key pinning allows you to tell your browser that it is accessing website that has certificate for your domain, but not issued from the certificate authorities that you defined with the pinned keys. And the browser of the client can reply, actually, it will open this URL that you defined with report URL, and it will tell you that there is a problem. Keep in mind that this may be a very good DOS situation, where it's not DOS, it's distributed DOS. Because if you have a problem with this, every browser that is accessing your site will report this to your URL here. If this is on the same machine that is also hosting your main site, it's a DOS, DDoS, sorry. So keep this in mind. The next thing that I want to share is with the public key pinning, there is a bigger issue, because if somebody compromises your website and puts this header with his certificate and his key that is pinned for your website, now your website is hostage to his key. So for this reason, I would strongly suggest that if you don't use public key pinning, you should definitely strip this header on your web servers. So even if your website gets compromised, you should not put this header out there. This is a big issue. And because of the max H, this is stored on the clients, you cannot tell any client that they have to remove something from their browser, which is not actually easy for the public key pinning, because there is no easy interface in the browsers to remove this cached information. So there is an interesting article that you should read about this. Yeah. So The other thing, so now we're continuing with HTTP headers only. Mostly to the end of the talk, I will be talking about HTTP headers. Most of you should know about the strict transport security, most of you. The idea here is that you need to secure the access to your website to be only through SSL, right? But be careful with this, because if you set this and you have set the report URL on the public key pinning, or we will see the exempt CT headers, report URLs, and you set this and you have invalid SSL, now nobody can access your site, and you cannot report this simply because your reporting URLs are also via SSL. So try to keep the reporting URLs on HTTP. This is one of the valid reasons to run HTTP. The other valid reasons are simply because your data doesn't need to be encrypted at all. So the strict transport security also have include subdomains. So when you have loaded something on your website, and the website also requests some URLs that are from subdomains of your website, this transport security also applies to the subdomains that you are requesting. Also, you may tell it to try to prefetch these to test if the resources are available via SSL, and if they are not, it will again alert the browser. For the strict transport security, you have to know that it's a click-through security. This means that the browser gives an option to the client, to the user, that he can ignore the warning and continue to your website. So this is not a complete solution, or at least when you have warnings from this, your users can reach your website. The other thing about strict transport security is that it can be used as a super cookie. What this means is that based on the information the way you're using the strict transport security, you can actually identify a user between different sites. So this is a bit problematic. Now, if you set this, if you usually when you're deploying your website have issues with mixed content, if you use this header, now you don't get any content. Simply because all the content that was marked as the mixed content, but at least partially loaded, now it's not loaded at all. You don't have warning, you simply don't get the content at all. It's a strange situation, but most of the people that I know, they use frameworks that really don't know if the site was accessed via SSL or not. Actually, they know, but they don't care. So when they're implementing the creation of the transport security header, they simply don't care if it is via SSL or HTTP. However, the RFC defines that this header should be sent only via SSL. So it shouldn't be valid, and it shouldn't be sent over HTTP. You can read the RFC there. The origin concept of the web, something that is fundamental for the rest of the security that I will be talking about is we want to be able to understand what the browser wants from us. So where this page came from. Because you may load one web page from google.com and the same web page from a CDN from somewhere. And you want to know where this page that is accessing your website has been loaded. And this is where the origin header comes. And this is a request header. This means that the browser is sending this. The origin header is used for the cross-origin next slide, sorry. For the cross-origin requests, and you see where we can, how we can use it. The main thing here is that origin sets a scheme that means that origin is different for HTTP, HTTPS, FTP, or whatever that you're using, and it also includes port. I have to note here that the port is handled differently in different browsers. This means that if you set the port to 0, for some browsers it won't care. But for some browsers it would say that this is completely different origin. Origin is used mainly in the AJAX requests, but also, as I said, is used in the cross-origin requests. And the same origin policy is something that every web developer should know. And here is a semi-table which defines what is same origin here and what is actually not a same origin. And here you see that the port depends on the browser. So now, for example, if you're opening this on, was it iPhone or Android, I'm not sure, this may be the same as with your whole phone. Yes. Not the same like this. It should be without the port here. So it may be the same like www.1h.cx/dir/all.html, or depending on the browser, it may not. First, why we have the same origin policy? The idea was pretty simple. If we have opened a web page from certain domain, all the resources that are loaded dynamically, JavaScript, CSS, and stuff like this, should be loaded from there. Or, I'm sorry, all the JavaScript that tries to request something should request only resources from the website where you loaded the web page from. This is the idea of the same origin. However, you have to keep in mind that most of us are using browsers, single window, with multiple tabs. And on these tabs, there is a way to make two tabs communicate. Actually send data from one tab to another. And in order to do this, you have to be able to relax the same origin policy simply because one of the tabs may be from one domain and the other tab may be on another domain. So what you should do to relax the same origin policy is set in the JavaScript document domain, the document domain property to the same top level domain, which may not be the top level domain, which may be, for example, facebook.com, which is opened on the first or second tab of your window right now. So here's what we have. We have two subdomains, M1 and M2. They may be windows or frames, opened in windows or frames, we don't care. On both windows or frames, we set the document domain to 1h.cx. Now both tabs or frames can communicate in between each other. They can actually read, not the whole DOM tree, but they can send data between each other. The other thing when you're relaxing the same origin policy is the window is a single window, and there for the window we have one interesting event here on message, which can be triggered from one tab, and it will trigger all the tabs that are on this window right now. Which means that if they have something on message, this website X has event on message, and I'm the attacker. I'm reading the on message and giving this data to the other side. The other side will use my data, the info that I gave it. So this is the interesting situation here. So same origin is actually not the best security policy that you can rely upon. This is why we have the cross-origin resource sharing course, and it has a few headers that your browser sends to the server. First is the origin. Also, you can say to the server which methods you're going to request. This is from your AJAX request. So you can say to the server, I would want to do a put request, or I would want to do a post request. You can define this in the access control request method. or you can also define what headers you would request from the server. And this means that the server now have to decide, should it allow you, should it give you access to the resources on the next request? Because these requests are made with the options request. It's in the options method. So the server can give you more information. Like, I want to allow you, I'll show you this in a bit with the origin. I want to allow you to load my resources. I want to allow you to send me credentials. I want to expose to you these headers. This is the maximum cache time that you would do. These are the allowed methods that you now have access to. This is very nice when you're combining this with the request headers here. Okay, if you're not requesting some headers, now your application knows what headers actually the server can provide to you. Oops. So let's say that we have opened gs1h.cx and we have sent the origin like this with the options. Now gs1h.cx is returning to us that it is allowing us to load from, if we have opened the resource from www1h.cx, it allows us to load from this origin, which is not gs1h.cx. The other thing is the asterisk here. It can allow everything. Why this is at all possible? Simply because you may want to have a worldwide visible resource that is on a CDN, for example. In that case, if it is publicly available and should be publicly available, then most probably you want to give it the asterisk here. By the way, if you have any questions, stop me now when you are still on the slide here, because otherwise we'll continue. When you're using the asterisk, you have to keep in mind that secure cookies, credentials, everything that is considered secure for your browser is not sent over the wire. Even if you're using HTTPS to connect to the site, it's not sent to there. Now, course is not is not checked for everything. So it's responsible for AJAX requests and fetch and the fetch API for web fonts. So keep in mind that web fonts are part of the CSS, but not actually. So the browser can differentiate these. Also, WebGL, images, video frames, style sheets. As I said, they are different than web fonts, and scripts. So this doesn't change the fact that you can download the HTML from everywhere. The cross origin resource sharing is not for the HTML itself. So it was supposed to mitigate the problem with injection attacks, but the content security policy. Sorry. So the problem with content security policy is that it's so big in what you can do with this that it simply sometimes complicates the things more. So let's see. I think there are a little bit more, but these are 23 different options that the content security policy gives you. So the developer now has very granular access to control, not access, to what the browser should allow to be loaded and from where. The problem is that it's actually too much for most of the developers. This is why this is most of the time not used. If you check the most popular sites, they use some of it, but they do not define a lot of content security policies. So why is that? Obviously because we have different parts of all of these are different parts of requests. For example, AJAX requests are the first thing here. And then we have for style sheets, for scripts, for forms, for everything. We have different objects that we have to supply and control. And usually when you want to do this in a large scale, you have to actually have a framework that can define these for you, and they can be included in your web project, which is not very easy actually. So the values of most of the content security policies are you can disable the questionable thing, like you can disable loading of images, you can disable loading of scripts, you can disable whatever, something from the 20 different types. You can also tell from where it is allowed to load, which is very nice. These are the source lists. And the other thing is the media type lists. Media type lists are actual MIME types that you want to filter. So you may say that you want to load all images without SVGs. That's fine, because SVGs can be used to abuse your site. So let's see how we can set this. We can set it in the content security policy can be set with HTTP equiv meta type, or you can set it with the headers, as most people are doing this with the headers. You can define then one or more definitions here. Keep in mind that you have 2 kilobytes, one line for one header, and this is one header, and with 23 different options for this header, it's pretty easy to actually fill 2K of data only with access restrictions. It seems funny, but it's possible. The rest, content security policy was a good idea. Very nice idea. It was accepted a long time ago. I think it was 2009 or something like this. But it was broken like 7 or 8 times. The most prominent things here are the 2015 CSP nonce attack, and the script gadgets is from August last year. So these are the links to the attacks themselves, so you can read about that. And the other thing is that most of the websites, in order to load fast across multiple countries, they're deployed on CDNs. So their static content is on CDN. The problem with this is that most of us don't run their own CDN. And when you don't run your own CDN, you actually allow somebody else's CDN. And since you're a client of this CDN, the attacker can also be a client of that same CDN. And you actually allow all the static content of the attacker to be loaded on your website with the content security policy, which is not very nice. The other things, when we are talking about CDNs, we want to verify what we are loading. And the sub-request integrity is something very important when you're working with CDNs, because most of us usually load scripts directly from the CDN with the source, and that's it. Some of us may remember that there is a course, the cross-origin resource sharing, and you can actually use this to say how you want to handle this cross-origin request. Or you can use the integrity here, and the integrity defines 4 SHA functions. Currently I'm showing you here SHA 384. You simply define the name of the SHA function that you're using, dash, and this is the base 64 of the result of the SHA-SUM. So what you're doing is you're generating a SHA-SUM of this JavaScript here, and the browser will generate the same SHA-SUM and verify if it is this number here that you have given. So if for some reason your JavaScript have not been uploaded correctly, it's an old version, or an attacker has replaced this JavaScript, your browser now knows that it has a different SHA-SUM, and it wouldn't load this this resource. It's the same for CSS. Okay, so the sub-requests, this is the definition for the sub-request integrity. Integrity can provide multiple digests. This means that you can have, for example, SHA 256 digest and SHA 384 digest, and both should be verified. So that's not a problem. The content security policy has an option for sub-request integrity, and you can enable this for the scripts only, or for the styles, or for both things. Okay. Content type options. This is pretty simple. You're saying to the browser, "Your stupid browser, don't do shit. Simply believe me that I'm giving you GIF or PNG or whatever." Browsers try to be very polite to users and not give errors when somebody didn't send content type. And they try to find out what the content type of the file was. So when you're sending, for example, a PNG, which is not a PNG file, but HTML or worse, JavaScript, the browser, if it doesn't have the no-sniff content type option, it would load this file. It would find out that it's not a PNG, and it would actually parse it as a JavaScript because it finds that it's a JavaScript. And now you have code injection on your website. So no sniff should be the default for everyone. I don't think there is a valid reason that you shouldn't do this. I have a few, but okay, they are not for the camera. The other thing is X-XSS-Protection. This is a header that maybe in a few years we won't need, but right now it works for Internet Explorer and Chrome. Mainly for Internet Explorer, it's important that it enables cross-site scripting protections inside the browser itself to prevent these types of attacks. It's a nice header. It's an old one. For everyone that has to be compatible, banks and stuff, this is something that you should include in your web applications. The idea is that you either enable the protection, disable it, or when you enable it, you don't allow the browser to click, the client to click through, to go through your warning and continue to the site. With the block, you simply disallow the client to. The client will not be able to load a page that has XSS on it. H-frame options, it's again very old, some header that you should know about. The idea is that you don't want to be able to get data from a frame or iframe within your website, within your page, and this frame to get data from the main page that you have loaded. So you can define, you can tell the browser, should it at all load frames, deny, or should it all frames or iframes from the same domain, that from the same host that the page was loaded, or from which hosts it should allow iframes and frames. So it's pretty straightforward. I hope you all know what clickjacking is. So yeah, looks like this. Permitted cross-domain policies. This is something that we also may not use it in a few years. The idea is that this header defines a URL to an XML, and this XML defines policies for Flash and PDF readers to allow loading of dynamic or cross-origin content from your page. So on your page you have a Flash, okay, that's fine. You can tell the Flash player which other domains it can load data from, which is very important because actually Flash doesn't follow the cross-origin request sharing mechanism. This means that Flash can open everything. Also, Flash doesn't follow the content security policy because it doesn't know about them. this is the only way that you can tell the Flash player which hosts are allowed to load data from. The same goes for the PDF readers. Currently, I think only the Adobe PDF reader does this, but I'm not sure for the others. Possible options are we don't have policy for this, so the Flash and the PDF cannot load anything only from the main hosts, so same origin. By content type, you can define which content type has which XML. You can also say that the only XML would be cross-domain XML, or you can allow everything, which is actually the default, so it's useless. The other is referrer policy. Referrer policy, everyone knows what referrer is. However, not everyone wants to send referrer to Google, Facebook, and whatever. So you can say that say to the browser not to send referrers, which is quite nice. And you can use the referrer policy here, header. It can prevent information leakage of data into the GET request or privacy information. Actually, you can use the referrer to prevent even session leakage when you're sending your session ID in the GET, which somebody still does. I don't know why. So you have all of these options, but I don't have time, so you have to read on that link there. Expect certificate transparency. Who here knows about certificate transparency? Only a few guys. Sorry. So the idea is that when you buy a certificate from certificate authority, you don't know if this certificate authority have created another certificate for your domain. Also, you don't know that another certificate authority also have created a certificate for your domain. What you would want is to know about these things. And the certificate transparency is idea of Google that we should have a log, distributed log, crypto secure log that cannot be easily changed. So every certificate authority will submit every creation of a certificate to this log. And everyone could audit this log. Everyone can subscribe to events from this log. Like, for example, I would want to subscribe to siteground.com because this is a very important domain for me. And I would want to receive every notice about certificates that were created for this domain. So the certificate transparency is quite a nice idea, and it actually works. The idea is that when a certificate is created, it is also timestamped, and the information is given to a digest of this information of the created certificate, and the timestamp is sent to the log and also written inside of your certificate. So when you get your certificate, you can actually check if your certificate authority has actually published your certificate to certificate transparency log. So since you have this, the certificate timestamps, the signed certificate timestamps in your certificates, you can send to the browser now this header, and you can say that this certificate that it loaded, it's valid for this time. Even if the certificate is not checked for, this means that this certificate will not be checked anymore from the OCP sampling. It would simply verify that this is the certificate, and it was in the cache for the certificate transparency certificates, and it will believe that this is the certificate. The problem with this is that now you cannot revoke the certificate. For the people that actually know what this means, it's quite problematic because the browsers now would still continue to believe that this is a valid certificate even if it was revoked. You can either enforce this or only report the information that there is a problem with your certificate. Again, you have here a report URL that maybe shouldn't be on HTTPS. supported by Chrome and Opera. Firefox is still pending, but I hope that within a few months we'll have it in Firefox. Now the cookies. Everyone should know this. We have the secure cookies, the HTTP-only cookies, and same site. This maybe not everyone knows. So the secure cookie is pretty simple. Every cookie that is marked secure is sent only via HTTPS. That's it. This prevents session fixation attacks, leakage of sessions and stuff like this, leakage of private data. Very important. I don't know why you should have a non-secure cookie when your website actually redirects to the SSL. So the HTTP only is a misleading option for everyone that is confused by it, like I was the first time. It actually says that JavaScript, that this cookie shouldn't be accessible by JavaScript. It means that it would be accessible only for the web page itself, but not JavaScript. This prevents JavaScript from reading secure data from your website. Same site is something new, they say new. It helps fight the cross-origin request forgery problem by defining that a cookie should be actually loaded only from the same site with the strict option, or you can define it that it can also be loaded from the top-level domain, which is a little bit strange. Same site is, for example, scripts.1h.cx, but if I want to load this cookie from that was set from 1h.cx, I cannot right now if it is strict. But if it is lax, actually it allows you to read from the top-level domain. This way you can actually use the same site in two different ways. Like, for example, Amazon used this same site option for, okay, I'll skip this because I don't have time. Sorry. So PHP doesn't support this. And the last thing, security.txt. I advise you to everyone to create this file on your website. It should be most probably in .well known, security.txt. This is a file that allows security researchers to respond, to tell you that you have a security problem on your website, and you're defining how this is happening. And if you want the data that that they're sending to you to be encrypted, you can define your PGP key here, so they can encrypt with your PGP key and give you data that only you can read. Actually, you can tell who to contact here. You can tell what is your security policy, like what you want reported and what not. And most of us are doing also Half of Fame. So for everyone that has reported free of charge some security bug to us, we simply thank them on this page. And I'm sorry, you will have to read about this later. Thank you. I have some questions maybe. Перфектно беше това с таблета. Начиняваш с опра тази лекция.
На мен просто са направили на друга конференция и знам, че...
Извинявай, какво мисля за OpenSSL? Мисля, че Google казаха, че от няколко месеца няма да го защитат повече с те безплатните SSL сертификати.
Сега малко OpenSSL в библиотека.
Да, има преди те безплатните...
Let's Encrypt е?
Да.
Първо Google са един от най-големите спонсори на Let's Encrypt, така че такова нещо няма, не? Това е някакъв фейк нюз. Да,
Не, с Linux. Моля да без обиди.
Защото сега имаме границите малко